In this video, we look at the assembly of drill jig parts. The modeling of the parts were shown in the previous video. The first part was block. The second as the handle. We missed a feature in this in our last video, a hole drilled through. So let's complete that. It is having a circular profile as seen from the front, making the front plane a sketch plane. Going normal to it and sketching a circle which is having a vertical relation, the center of which is having a vertical relation with the origin. This has a diameter of 2.9 and positioned at a height of 10 mm from the bottom edge. Let us cut extrude on both sides. To generate a through-all hole on either side of the handle. We have the third part as the screw. Fourth one being the bushing. And finally the pin as the fifth part. To make an assembly, we create a new document using the new file option under standard toolbar. Select the assembly file. We have the following documents open, which are listed here in the property manager. We select the block as the first part to be included in the assembly. We get in the second part using insert components under assembly toolbar. Select the screw and place it at the top of the block. Click on insert component to get the handle in here. We repeat this to get the pin and the bushing. The bushing are two of these, so you can get another one of the same part. To add the mates, we'll try to assemble the handle, screw and the pin, and then the three together into the block. We have a concentric mate between the cylindrical faces of the handle and the screw. Select the two surfaces. Under mate, assign a concentric mate. Move the screw a little bit down to have a look at the inside surface of the drilled hole with diameter 3 and 2.9 in the handle. With those two selected, assign a relation of concentricity again. The pin needs to pass through both of these two components. Select the outside surface of the pin, inside surface of the hole drilled in the handle. Assign it a mate of concentricity. The flat end of the pin can be assigned a tangent relation to the curved surface on the cylinder. This is already tangent. Click on the move component and try to move the three move together. Okay, they revolve together. Then comes a screw mate between these two features here in the block and the screw. Before that, we assign a concentric mate between the cylindrical features. So we have the boss at the bottom here, and we can pick up the surface coming from the minor diameter of the threaded hole, or you could also pick up the curved surface on the outer side here. Both of these are concentric, so it could apply to the feature above as well, where you can have concentric made between those curved surfaces. Now the vertical movement between the screw and the block would be possible only if you rotate the handle. This is because of the screw having a threaded feature. So in this case, we make use of a mechanical mate. Under mates, open up the tab for mechanical mates and then select screw mate. Make the selection as the axis of the screw and the axis of the threaded hole in the block. Turn on the temporary axis. Once you make them visible, assign the axis of the block and the axis of the screw to have a screw mate between the two. You have the direction of rotation here. This is a clockwise direction. This is a right-handed screw, so we have it moving down or advancing into the nut when turned in clockwise direction. The distance that it travels per revolution, we'll consider this to be 2 millimeters, as we have this as a single start point thread with a pitch value of 2. So the lead here will be 2 millimeter. Now you can hold the top of the handle and try to rotate this. Let's turn off the temporary axis before we turn the part. Hold the part from the handle on the top, rotate it to observe the movement downward into the block coming from the screw mate. Now the handle goes in down and at the most can strike the surface, cannot go further below that, and the bottom of the screw bottom of the screw and the top of the anvil here on the block do not strike each other because of the constraint that we have on the top. So we can assign a distance mate between the bottom of the screw, this face, and the top of the face on the block. So this would be the two faces between which you can assign the distance mate, or it could be between this face and the bottom of the handle. So pick any of these two and then give a distance mate. I select this face here at the bottom, the other face on the top. So these are the two working surfaces on which the object would be clamped. We give this as a distance mate, so that too as an advanced distance mate with a limit. So you have under advanced mates, assign the distance here. We assign the distance between the two flat faces, uh, the bottom of the screw and the top of the block, extended portion of the block here, as the distance 88 minus 22 minus 38. So the remaining distance between here is 28. So that's the maximum possible distance between these two faces, and the minimum that you can have would be when this handle is completely rotated and comes down to rest on the top of the block. In this case, you'll have the entire length of the screw inside the block here. So this is 34, and the remaining portion would be hanging down. So you have 58 as the length of the screw. You subtract 18, which would be moving into the handle. So the leftover portion is 40, and you have 38 as the other height. So if you subtract this from 88, you'll be left with 10 as the minimum gap between the two faces. So we'll assign these two limits of a minimum value of 10 and a maximum value of 28 between these two faces. We select distance, and the maximum distance is 28 and a minimum of 10 millimeter between the selected faces, and accept this. Going over dimetric view, try to hold the top of the handle, rotate this until it goes down completely, striking the block. It has reached the limit of a minimum gap of 10 between the two faces. So as you try to rotate, it does not go down further and has got constraint there. In the same manner, as you keep rotating this in the counterclockwise direction, it will come out but doesn't move out completely. When there's a maximum distance of 28 between the two surfaces, that stops there. It can come out completely, but for simplicity's sake, we try to restrict the movement in the opening direction. We then have the bushings to be included into the assembly as they go into the block. We have the two surfaces here. Assign a concentric mate between the selected faces. The flat end of the bushing and the frontal face here on the block, they are coincident to each other. Similar mates are to come onto the other bushing. Appropriate tolerances needs to be assigned on the pin and the hole in the handle. We have the hole size as 2.9 and the pin as 3. Locational interference will be considered between the pin and the handle with the fit symbol of P7 at 6, considering shaft pieces system between the handle and the pin. Let us add the tolerances on the pin and the hole on the handle. We edit the pin change the dimension 3 to have a fit with tolerance with the shaft fit as at 6. Make it up to 3 decimal places and then rebuild. Exit the part. We also add tolerance on the hole in the handle. Edit the part for handle. In the sketch for the circular hole, edit the sketch to add a tolerance onto the dimension 2.9. Exit the edit part. Make necessary changes to the thread feature on the screw and the hole in the block to have the thread properly fit into the groove of the thread in the nut. This can be done by opening up the thread feature on the screw and assigning an appropriate offset. So let's make it a 2-view window. We give the offset by 2.75 millimeter and 270 as the offset angle for the screw. Let's make the thread form visible. So you have it in here, the same as can be seen in the dimetric view over here. In a similar manner, update the details for the thread on the block. Let's make the thread profile visible. We have got the other one here. This is having an offset of 1.5 millimeter 90 degree. So it starts in from here, and the same thread profile is shown in the other window. By doing so, let's make this transparent. By doing so, we make sure that as we rotate the handle, we have the screw moving into the groove here. Let's try to change these values here. So now you can observe that value of 3 was appropriate. You can just look at the number which is appropriate to align the helical grooves that you have in there with the ridge coming on the screw. Now as you rotate the handle, you will find the thread to move into the groove that's made in the nut. We hold it here. Okay, this completes the 3D assembly.